When dealing with the expression infinity raised to the power of 0, we encounter an indeterminate form. To solve this problem infinity raised to the power of 0, we are going to work through on this problem, that is limit x tends to infinity x raised to the power 1 over x. If we substitute x as infinity in this function, then we are going to get infinity raised to the power of 1 over infinity. 1 over infinity is nothing but 0. So infinity raised to the power of 0, which is same as our question. So that if you want to find the value of infinity raised to the power of 0, we are going to work through on this problem. Limit x tends to infinity x raised to the power 1 over x. So let's take this. So when you substitute x as infinity, we are going to get infinity raised to the power of 0. But it is an indeterminate form. In limits, whenever you are getting indeterminate form, we are going to apply the L'Hospital rule. What is the L'Hospital rule? The formula is limit x tends to some constant f of x over g of x, that is equal to limit x tends to the same constant f derivative of x over g derivative of x. That means L'Hospital rule, it is in the form of f of x over g of x. So whenever you have in this form, you need to do derivative of f of x over derivative of g of x. That is the L'Hospital rule. But observe the given function. What we have function? Our given function is x raised to the power of 1 over x. In L'Hospital rule, that is in the form of rational form, f of x over g of x. But our given function, it is not in the rational form. It is in the form of exponent form. So first what you have to do, we need to convert this exponential form in terms of this rational form. Then you have to apply this L'Hospital rule. So that's why I'm going to try to convert this given function x raised to the power of 1 over x as in terms of a rational form. So for that, let us consider f of x as x raised to the power of 1 over x. Here x is in the exponent. We need to apply the natural log on both sides, isn't it? So let's apply the natural log on both sides. Ln f of x equal to ln of x raised to the power of 1 over x. Now it is in the form of ln of a raised to the power of m. So we can write this as m times ln a. So like that, the right hand side turns into 1 over x ln x. So this we can write it as ln x over x. So we convert in terms of a rational form. So the left hand side is ln f of x, isn't it? So now what you have to do, you have to apply the limits on both sides. Let's apply the limits on both sides. Ln limit x tends to infinity f of x, that is equal to limit x tends to infinity ln x over x. Now the given function x raised to the power of 1 over x, we convert in terms of a rational form. So ln x over x. So now we can apply the L'Hospital rule. What is the L'Hospital rule? Limit x tends to constant f derivative of x over g derivative of x. So that is equal to limit x tends to infinity. So our f of x is ln x, g of x is x. So derivative of ln x, that is 1 over x. Then times derivative of x, the value is 1. So overall it comes 1 over x only. Now substitute x as infinity in your 1 over x. Then 1 over infinity. So 1 over infinity is nothing but 0. So the right hand side turns into 0. So that means instead of right hand side, I am going to write only 0. So what we got? Ln limit x tends to infinity f of x, that is equal to 0. Our goal is to find only limit x tends to infinity f of x value, not ln. So now we need to remove this ln. To get rid of this ln, I am going to apply exponential on both sides. So e raised to the power of ln limit x tends to infinity f of x, that is equal to e raised to the power of 0. So now in the left hand side, exponential and logarithm, these two are opposite function. After get rid of that, we left only this limit x tends to infinity f of x. So let's take only that limit x tends to infinity f of x, that is equal to e raised to the power of 0. E raised to the power of 0, the value is only 1. And we consider f of x as x raised to the power of 1 over x. Let's write here f of x as x raised to the power of 1 over x. So now left hand side substitute x as infinity. So what we get? Infinity raised to the power of 1 over infinity. 1 over infinity is nothing but 0. So in the exponent we just write as a 0, that is equal to only 1. So finally we got infinity raised to the power of 0, the value is 1. I hope you like this content. If you like this content, please subscribe to my channel. Your support means a lot to me. Thank you for watching.